right, let's go ahead now and do the integral of sine squared dx. Now there's a fairly standard way to do this, which is to take advantage of the fact that the double angle formula for cosine can be written as 1 minus 2 sine squared of x. And so you could rewrite sine squared of x as then being 1 minus the cosine of 2x divided by 2. So the integral of sine squared of x dx is actually the same thing as the integral of 1 minus cosine of 2x over 2 dx. And that's a simple u substitution integral that you can just do. But this method requires using the double angle formula, which I don't think a lot of people sort of have floating around their heads. In fact, I'm not sure I've ever seen the double angle formula for cosine used for any purpose other than this. So I want to do this in a way that doesn't rely on a trig identity that we use literally only to do this, which sort of feels like at that point we should just memorize the formula for the integral of cosine of 2x rather than memorizing another formula that lets us derive the formula for cosine of, or that lets us derive the formula for the integral of sine squared. Okay, so what else could we do? Well, one thing we can do is we can try to do integration by parts. And what are the parts going to be? Well, as it happens, there's very few choices for what I could possibly want the parts to be. Because all I have here is a sine squared. So I can let one of the parts be 1 and one of the parts be sine squared. Or I can go ahead and I can let one of the parts be sine of x and the other part also be sine of x. When I do that, then what's going to happen here is that d is going to be cosine of x dx. V is going to be minus the cosine of x dx. And by the integration by parts formula, I am going to get that this whole thing is now going to be equal to uv, so that is minus sine of x cosine of x, minus the integral of v du. So that's minus the integral of minus cosine squared of x dx. Okay. Which is going to, and I'll go ahead and I'll write it this way, that's saying that the integral of sine squared of x is minus sine of x times cosine of x plus the integral of cosine squared of x dx. Okay. Now it probably figures that if you didn't know how to integrate sine squared to start with, you probably also don't know how to integrate cosine squared. So it might seem at first like this hasn't helped us at all. But you might remember when we did the integral of, say, e to the x times sine of x, how we sort of like did integration by parts twice, and we got back where we wanted and we were able to solve for it without ever really doing it. And that was pretty cool. So you might try that here. Namely, you might say, okay, so now I'm going to do integration by parts again, letting u equal cosine of x and dv equal to cosine of x. But you'll be disappointed with what happens if you get that, because then you turn everything back, and in fact you get the equation that's the integral of sine squared of x dx is equal to the integral of sine squared of x dx, which does not actually help. But the idea is a good one. Namely, we can actually relate this integral here back to the integral of sine squared by using the identity here, our favorite trig identity, that I take this, it's the same thing as the integral of 1 minus sine squared of x all dx. Okay, and so, continuing onward, that gives us minus sine of x times cosine of x plus x, because x is the integral of 1 here. That integral comes down there to be x. And then minus the integral of sine squared of x dx. So I want to summarize what it is we just showed. Namely, what we just showed is that if you take the integral of sine squared of x dx, that's the same thing as minus the sine of x times the cosine of x plus x minus the integral of sine squared of x dx. And this is actually, despite looking bad, because we've got a sine squared over here and a sine squared over here, this is actually the good place to be, because what I can do is I can add this integral of sine squared of x to both sides, which will in fact give me 2 times the integral, of sine squared of x dx is equal to x minus sine of x cosine of x plus c. And so that means that the integral of sine squared of x dx is x minus sine of x cosine of x over 2 plus c. Okay. And now I would encourage you that if you are going to remember a formula for the integral of sine squared of x, that this is the formula to remember or write down or whatever, because this formula actually will end up being much more useful later when we're doing other integrals. Okay. So I want to point something out, though, before we wrap up. So namely, I want to go back to when we said, hey, if I take this double angle formula, I can integrate sine squared in the following fancy way. Okay. And I want to see what we get as our answer. So namely, if I rewrite this, this now becomes the integral of 1/2, which is just x over 2, minus the integral of cosine of 2x over 2 dx. And so that is x over 2 minus, okay, and you can see here that if I take u equal to 2x, then I'm going to have to divide this by 2 again. And so I'm going to get sine of 2x over 4 plus c. And that'll be my answer here. Now, it might briefly upset you that that answer and that answer are not obviously the same. Namely, this answer and this answer up here. But, in fact, to resolve this seeming discrepancy, the thing we actually need to know is we actually need to know the double angle formula for sine of 2x. Namely, we need to know that sine of 2x is 2 sine x cosine of x. Okay. And if you substitute this 2 sine x cosine x in for this sine of 2x, then it's not hard to see that in fact what you're going to get is exactly the same thing that we got up here. And so that shows you both ways that you could integrate sine of x, or sorry, sine squared of x.